Good morning, everyone, and thank you for joining the Market Surveillance and Committee for today. My name is Jimmy Bashar with the ISO Stakeholder Affairs Group. As a general reminder, we do have our Stakeholder Symposium coming up on October 17th and 18th. Seats are still open, so we do encourage you to go to our website under the Stay Informed tab and click the Meetings and Events link. And you notice all the details on the agenda on that event, and we're very excited about it, and we encourage you guys to sign up as we do still have seats open for that. And as general instructions, as you know, please press #2 on the phone if you have any questions. We'll be pausing for questions throughout. And we do ask that you state the name and the company that you represent. And with that, I think we're ready to get it started.
Good morning, everybody. This is Ben Hobbs, Chair of the Market Surveillance Committee. And with me today are MSC members Jim Bushnell and Scott Harvey. We've got an agenda with stressing local market power mitigation enhancements, 15-minute granularity in the day-ahead market, and finally a review of reliability must-run and capacity procurement mechanism. But as is usual at the MSC meetings, we start off with an opportunity for public comment and invite comments first from anybody in the room and then folks in the lines on any issue other than issues that we'll be discussing later, unless for some reason you can't participate in later discussions. So first I'll glance around the room and see if we have anybody eagerly waving their hands for public comment. No public comment from within the room. Operator, could you see if there's anybody on the phone lines who has a public comment at this time?
At this time, there are no verbal questions.
Okay, thanks very much. Okay, the next item on the agenda is a decision concerning the minutes for the last general session. And this was the August 3rd meeting that we had. So I would entertain a motion from either Jim or Scott. Oh, I've stolen your mic.
I move to accept the minutes.
Second.
It's been moved and seconded to approve the minutes from the last MSC meeting. Any discussion?
No.
Seeing and hearing no discussion, I'll take a vote. First, Jim?
Yes.
Scott?
Yes. And
I vote yes. So the minutes have been accepted unanimously. And at this point, I would like to invite Don Trethway, who will be talking about local market power mitigation enhancements. This has a lot of interesting features, from DEBs for big hydro plants to reversal flow, and so I imagine we're going to have an interesting discussion. This discussion will take scheduled to take the rest of the morning, so there's plenty of time. Okay, Don, thank you for coming.
So good morning, everybody. Unfortunately, the screen in front of me isn't working, so I'm going to have to crick my neck the entire time. So we're here to talk about the local market power mitigation enhancements. We put out an issue paper straw proposal about a week ago, and so we're in the early stages of this initiative, and it covers several elements. Prior to putting out the issue paper and straw proposal, we held some workshops because there were some concerns with regards to mitigation within the energy imbalance market. So we worked through those through 2 workshops. And then we also discussed the last Market Surveillance Committee. Scott Harvey highlighted some potential issues that we would need to address as well, given the observations that we had seen when PowerX came live. So as we dug into the issues, we found that it was actually broader than just a default energy bid issue. And so there are other issues around the mitigation that we wanted to tackle. So the first is with regards to the real-time market power. First was this observation of flow reversal. So this is where a balancing authority area would be import constrained, which would trigger mitigation. Then once those mitigated bids were used, you'd see rather than it importing, it becomes an exporter. And so we can address that by modifying the competitive LMP, ensuring that that's actually more accurately calculated. And this is really a broader market issue. It's not EIM specific. Next issue that we have is around when you have economic displacement, when two EIM entities become, that region becomes import congested. And then you could have the result of, since you mitigate all the resources within that those combined balancing authority areas, where you could see changes in the unmitigated exports between the two balancing authority areas in that bubble. And so we're trying to find ways to address that specific issue. Next is around the default energy bid. For some of the EIM use limited resources, the current approaches may not reflect the opportunity costs of being able to sell outside, recognize that there's bilateral transactions that can occur outside of the energy imbalance market. And so we're looking at coming up with an approach to develop a fifth DEB option to address this specific situation. We also wanted to make modifications to the reference level adjustments. So this will allow us to, in the event that there's significant changes in gas prices, that we could use that to update the reference levels. This is a broader market issue. And then we would also want to have a similar approach developed for resources using the use limited default energy bid option for the EIM, so that in the event that the input data to that changes materially, that you could also update that prior to the start of the real-time market. And then lastly, there was some issue around the gas price indices given the merger of ICE and Platts, I believe, but this is a significant item. So first I'll walk through some principles, and then we can have some discussion around that, and then we'll go through each of those elements in more detail. So when we put together the paper, we wanted to try to document some principles, and they're outlined in these next 3 slides. So the first is we would not want supply to be forced to sell its power below its bid price if it can't exert market power, but we also would want those supply bids to be mitigated to their marginal costs to the extent that there is market power. The next principle is we want to recognize that the EIM is a voluntary market and that each of the balancing authority areas should have sufficient supply to meet their own responsibilities. And so when we're given that case, when there is mitigation and there could be transfers between the balancing authority areas, you don't want that supply to be forced to sell and mitigated beyond what is needed to resolve the market power. Okay. Yeah, go ahead.
I think there's a question what we mean by beyond what's needed to resolve market power that we ought to be careful about, because just because there's only just so much of the dispatch at a particular price doesn't mean that the market power is resolved. And we also need to recognize that in some of these BAAs, it's not just the EIM entity that's a participant. If they're using that EIM price to settle imbalances of embedded entities within the balancing area, there can still be a market power concern.
Yeah, and I think when we discuss this specific item, I think if you look at the initial proposal where we were limiting incremental exports, you may want to do something a little different than that, recognizing that, yes, it's a voluntary market, but the amount that actually is being shown to pass your resource efficiency test is not quite as voluntary as something that goes above and beyond that, because you are relying on each other to capture the diversity benefits. So you may want to incorporate that into the logic in terms of how you would want to set that up.
This is Brad, ISO. I'd add that I was just thinking that, we could further refine this principle. When we say sufficient supply to meet its own load and reliability responsibilities, like Don said, that might not be just literally the supply they have within their own BAs to pass the various resource efficiency tests, but some accounting for the amounts of the diversity benefit that goes into those tests. And so I guess, we can't say that, transfers between EIM BAs should never be mitigated because each BA should be able to stand on its own because there is that diversity benefit.
That's my concern. We can talk more about it later, but I was worried about this principle being a little too broad. So,
Yeah, I think we'll get to this when we get through the examples as well. But yeah, I think it sort of gets back to this root of this example, and I think there are a couple, or this principle, and I'm still trying to get my head around whether this is the voluntary part, whether it's something else. But you know, some of the examples sort of illustrate that you can still have what looks a lot like local market power that raises prices, but still doesn't, you know, result in an export or a flow reversal, and how to think about that in the context of EIM, I think we need to talk through.
Okay, so moving forward, next is that we want the competitive LMP for each interval to accurately reflect the market conditions in that interval. In the 15-minute market, this is straightforward because we do the market power mitigation prior to running the binding 15-minute market. When we do run the real-time dispatch, we actually use the advisory interval of the prior market run to determine the market power mitigation. So I think this is a goal, but we need to recognize that in RTD there still is possibility for error in this calculation. Next, that we want the marginal costs of use-limited resources to accurately include the opportunity costs for future market sales. And then lastly, that we would want that in the event that those input data change similar for thermal resources with their gas price changes, we would want to have an ability to update the reference levels. And then lastly, we do want those gas prices to reflect real-time volatility so that we can efficiently dispatch the supply and have more accurate market prices, which minimizes the need for after-the-fact cost recovery. So with that, I'll pause and see if there's any additional, any comments from the room or the phone, so, and if the MSC has.
Okay, so if we go back to the first slide, and this is perhaps beating on the dead horse that Jim was already beating, but the second principle is, it's the important word there is voluntary, and these are separate BAs. And now, if the BAs all agreed that we think because of diversity benefits, other things, that it's okay to reverse flow. If they all agreed to that, then we would not have this principle. But the BAs are basically driving the show. This is for their benefit, and if they've decided they don't want to see flow reversal for whatever reasons, even if they're economic benefits, then we take, okay, that's the principle, and we go with it. We design a market consistent with that. Is that basically the situation?
Yeah, I think we're recognizing that to the extent that you put more offers in beyond what's necessary to pass your resource sufficiency test, that's what I would consider sort of the pure voluntary, putting additional supply in for economic displacement. And we would want them to put that supply in because there are benefits for that. But if we would but if the fact that they could potentially be mitigated beyond those offer prices, if they don't put it in, I think we would be in a worse spot. So I think that's the balance we're trying to strike here.
Yeah, so I guess I could interpret that a couple ways, but it seems like most fundamentally it's that there isn't a must-offer obligation, and therefore anything that mitigates bid prices has this problem of if they don't like the mitigation, they could just pull it out of the market altogether. It does raise some interesting questions about what, a day-ahead design might look like versus, say, a full ISO expansion or something. But on the other part that you were talking about, Ben, I think, as Scott said, the BAA is not the only entity within its own footprint. And so should a BAA be able to unilaterally make that decision if there are other market participants within its footprint that may also have different views about that?
Yeah, this is Brad. I don't think anyone disputes that we should be mitigating within a BA when the BA is in part constrained because there's third parties in the BA, and the utility and the utility and the BEA can exert market power on them. I think the concern is more, though, when you're transferring energy to other BAs, whether that's market power, because they should be able to stand on their own. And there was transfers because everyone passed the resource sufficiency test, and they should be able to stand on their own.
Yeah, I mean, there's issues in terms of where market power stops and diversity benefits start, I guess, sort of that underlies some of that. And especially if you have two BAAs with dramatically different they may both be resource sufficient, but they may have very different costs in order to achieve that sufficiency. And if those differences are sort of taken advantage of through pulling certain resources out of the market, then that can still raise prices, and even if there isn't a change in flows.
Well, and there's the consideration they were resource sufficient. They passed the resource sufficiency test, but that resource sufficiency test does have the diversity benefit, which assumes a certain amount of sharing. I think the concern is, though, beyond that, whether the transfer should be mitigated.
Right, but this wording doesn't talk about that distinction between the amount of resources that are put in to achieve the EIM benefits as opposed to beyond that. And some of the things we're concerned about, like the flow reversal, is a case where mitigation is triggered, but then there isn't market power in the dispatch because you're exporting, so there's no market power. And so it's not quite just this voluntary issue.
Yeah, no, I
beat that horse a bit. But.
Yeah, I agree. We need to. We can refine this language. We realize it should be refined.
Yeah, I was just wondering. So the one issue that's come up in FERC, the former or prior FERC filings, and I don't know if the MSC was getting at this, is that even though you are mitigating all the resources that are bid in within a BAA, there has been concern in the FERC filings by various participants about the potential for physical withholding because you don't have a must offer. So I don't know if that was what the MSC was getting at, or I was going to there is the diversity benefit issue too, where the area may not be totally sufficient because of the diversity benefits.
I guess I was alluding to it. I'm still not sure exactly what to make of it because it's just overhung all these EIM, LMPM issues that the voluntary market aspect of it seems like there is this prospect of physical withholding that becomes possible, and I'm not sure how FERC intends to deal with that.
Yeah, the concern, and it's not physical withholding in terms of the volume, it's, not bidding in lower cost resources, bidding in the higher cost, so that would be the marginal unit. So, and that has come up. I'm drawing attention to that because FERC has expressed concern. They flagged that as a concern in markets without a must offer.
Any other comments in the room on these principles? Operator, can you see if there's anybody on the phones with comments on one of the three principle slides?
We do have a question. Please go ahead.
Hi, good morning. It's Mark Holman with PowerX.
Go ahead, Mark.
Hi, thanks. Just going back to that last principle, I think it's a really good dialogue, and I do think the principle should be modified. I guess the way we think about it is you can really look at it as two different ways in terms of that component that other BAAs are relying on. And this second bullet I really see as not about within the BA. This is about a balancing authority and resources within that BAA transferring additional export volume as a result of the mitigation. They're still able to transfer whatever volume is available based on their offer prices, but increasing those transfers. And I think there's maybe two ways to consider. One is to say, okay, in the EIM, you have other BAAs are relying on a diversity benefit from associated with all the BAAs passing the resource sufficiency test. So one way to look at it would be to say, okay, if all the other BAs are relying on or reducing what they're carrying by, let's say, 100 megawatts as a result of this other BA being in the market and the diversity benefit being calculated, then you'd always want to arguably allow up to 100 megawatts to flow and be mitigated, because the other BAs are relying on that diversity benefit to reduce what they're carrying to serve load. Another way to look at it would be to say the BAA that's exporting has to carry a certain amount of flexible capacity for resource sufficiency, and that's to meet both imbalances in its own BAA, but also to potentially serve transfers to other BAAs to assist in meeting their imbalances. And let's say that's 300 megawatts in the upward direction, and in a given interval, that BA has a negative imbalance of 80 megawatts, so 300 of that 80, or 80 of that 300 needs to be used to serve imbalances in the source BAA, then maybe the residual is the amount that should be allowed to transfer and subject to mitigation. You can always have higher transfers, but transfers on that, I would tend to agree with the way you described. They are voluntary, and the challenge is that for entities participating in this market, the EIM is just one of many different market opportunities. And if you mitigate in a voluntary market, and including the consideration that the mitigation is inaccurate, particularly for hydro resources, nobody really benefits because you discourage the voluntary participation in the first place. And so you don't end up actually mitigating it, you just end up chasing the supply away. So just some thoughts to consider on the principle.
So I think, Mark, your comments are consistent with maybe a policy of applying mitigation to the capacity that's obligated to be offered to meet the flexible need, but allowing no mitigation perhaps, or very much relaxed mitigation of anything that's voluntarily offered in excess of that. Is that right?
Yeah, that's correct. That you want to encourage the voluntary supply, but we need to consider applying mitigation against the supply that other BAAs are relying on. And there's a couple ways to consider doing that. That is going to maximize the benefit for buyers in the other BAs as well, because it's going to encourage that voluntary supply while still ensuring that the supply that is being relied on is subject to market power mitigation.
So I want to see if I understand the proposal. I think this is quite interesting, Mark. So of all, are you suggesting that of all the supply that's offered in a BA, that not all of it would be subject to local market power mitigation, but some amount that would be determined ahead of time?
I'm actually...
And so...
Sorry.
And so, let me just finish. And so let's say mitigation happens and you do have a flow reversal, or at least you have a change in the amount of power that's imported, as long as that's only because of changes in the operations of the mitigated resources, that would be okay.
Yeah, I think there's three ways you could do it. The first point you made is, and this one hasn't been considered yet, but you could say, okay, BAA1 is required to carry 300 megawatts of flexible ramping sufficiency up, or upward capacity, flexible capacity, to solve imbalances in that BAA, as well as to support transfers to other BAAs to solve their imbalances. One way you could do it is you could say the lowest price 300 megawatts in that BAA of energy offers, the most economic, are subject to mitigation. Anything beyond that's not. So that's one way you could do it. Another way you could do it is you could say, okay, I'm really going to focus on the transfer piece instead of limiting the quantity of supply offers that are mitigated, subject to mitigation. Once I get, maybe I limit my export transfers to, and this is, along the lines of what Don and Brad, I think, were saying, is that when you look at the component of limiting energy transfers to other BAs, you run the LMPM run, you get a certain transfer quantity, you don't increase that quantity as a result of mitigation unless it's necessary to increase it to provide that amount that other BAs are relying on. So you could say, okay, rather than do it on the supply offer volume, I could put an export constraint in that says, if the exports are zero, I'm not going to allow exports in the binding constraint to go above, let's say, the 80 megawatts of diversity that other BAs were relying on. But I will allow them to go up to that 80 megawatts to make sure I can get mitigated supply that was relied on. If the exports are already 300 in the first run, you wouldn't let them go above 300 because the exports are already more than what was allowed or what was needed for the diversity piece. So you could either do it by looking at the supply offers and saying the lowest price X within the BAA is subject to mitigation, or you could do it through the export constraint. But we've got to be really careful with those types of constraints. I think what you'd want to do is say it's just a limit on the export constraint, perhaps to the greater of what cleared in the LMPM run without mitigation and what the volume is that other BAAs are relying on for imbalance needs. That might be a way to make sure that we don't have, someone offers in 1,000 megawatts, the other BAAs are really only relying on 80 megawatts. They don't clear anything in the first run, and suddenly they get mitigated, and they export 1,000 megawatts at a mitigated price that may be inaccurate, and then it chases that supply away. So I don't know how well I described that, but I think there's a couple options here worth considering to kind of get that voluntary supply encouraged while still having appropriate local market power mitigations for the quantity that is being relied upon within the BAA and in other BAAs.
Okay, Mark, so I have a comment and a question. So I like your second approach better because of internal network constraints or whatever. It may be not the lowest price 300 megawatts that should be subjected. It might be something higher. And so the second option, limiting the transfer, would give the system more flexibility to deal with that internal congestion. And then the question I had was that 80 megawatts or whatever, the amount that other systems are depending on, is that a number that we know that is known ahead of time and can be put in the market software, that it's 80 megawatts or whatever?
So we do know the diversity benefit and the share that it's known before we actually run the market. Because remember, it's an input into passing the resource efficiency test.
Okay. So they know that
it is known. Okay. So it would be possible to put that as a constraint in the market. Okay. I appreciate your comment.
Yeah, I think we'll talk about this in more detail on this, but I think I just want to make one comment on it. This is addressing the issue when there are two EIM entities that become bubbled off from the rest of the system. Addressing the competitive LMP addresses a bigger portion of the issue in terms of the flow reversal. So I think when I look at this, we're sort of just taking a cut at things where we're seeing the issues and then getting it down to where we're left with a narrow issue that, okay, you're still going to be mitigated. Everyone agrees that we've got the appropriate level of mitigation. Now we just need to focus on the DEB. But we wouldn't want to make DEB changes to address these two issues because there's a better way to do it.
Okay. Mark, I appreciate your input. Do you have something else to add before we go to somebody else?
Two very, very quick comments. I agree with your first point on the internal congestion within the BAA. The first option I gave is probably less practical and very challenging to implement. That's why I agree. I think the export restriction makes more sense. So I think that's important. Having that number ahead of time really makes it valuable to know that you could actually apply this as an export constraint. I will say, though, that none of these different solutions are perfect or comprehensive. As an example, you could still clear a large volume in the LMPM run. Let's say you clear 500 megawatts of exports, and then you get mitigated on that 500 to an inaccurate default energy bid and can be harmed. So it doesn't fully solve. It solves the ability for other BAs to get the mitigated supply they need that they're relying on, but it doesn't solve the opposite side of the problem, which is you might still have harm to the seller if they clear a substantial amount in the LMPM run. That supply might be for economic displacement, and it's still going to be potentially mitigated.
Okay, Kelly.
Okay.
This is Callie Wells with WPTF. So I know I'm probably taking this to the extreme, but I'm going to just throw it out here for food for thought right now. We can talk about it later. But if we were to go down that path, could one then argue that non-RA resources within the ISO should not be subject to mitigation?
I definitely wouldn't want it.
So So again, I think the point I would point out is that for within the balancing authority area, every resource is still subject to mitigation. So the CAISO alone would still be subject to mitigation for congestion within that balancing authority area. I think the question is, would you have a similar rule for the ISO that you wouldn't allow additional exports beyond what we are carrying to pass the diversity benefit, just like any other balancing authority area in the EIM, so that you wouldn't dispatch more ISO resources at default energy bid prices to increase the exports out of the ISO. So I think you can apply this logic on the export to all of the balancing authority areas in the EIM.
Yeah, I was just food for thought. I know I'm taking that to the extreme there, but just wanted to throw that out there.
Wait.
Wesley from AC. Just a quick clarified question. When I think about the scope of the issue being covered, is this issue or potential issue will be a common issue for all EIM entities or just for a specific EIM BA that may not serve its own load, differently situated than other EIM BAs? We just want to get a clarify.
Actually, that you've made me think more about my previous answer, and I think this is probably just related for the EIM balancing authority areas because we would never get bubbled off by ourselves. And so I think if you correct the competitive LMP, then you wouldn't have any of the flow reversal or incremental exports out of the ISO.
But even within the EIM areas, there are multiple EIM BAs. Mm-hmm. And, there may be EIM BAs within California as well. So there are, I think, so the issue you're describing, I just don't understand if it's just for a specific EIM BA outside of California that does not have a load or are very differently situated than the other EIM areas, or this should be an issue applying to all EIM BAs.
So I think it applies to all EIM BAs except the ISO for the reason I just highlighted previously. So it's not whether the BA is located in California, whether or not this issue exists.
Okay, I was thinking about it, but it seems if you consider all EIM BAs, and also if you think about the market efficiency, if it's economic to serve other EIM BAs from, one EIM BA, then maybe like a market efficiency perspective want that result. But now you're introducing the additional constraint. I just don't know what the impact to the market efficiency from that perspective.
Okay, I think I'm going to move ahead to the various proposals, and then because I think we're talking about the second proposal in pretty depth, but we should, I think, walk through the first one, and then we'll
just make sure there's nobody else on the phone lines other than Mark. There's one other person. Operator.
This is Paul Nelson on behalf of Kika. I want to make sure people can hear me okay.
Yes. Thanks for calling, Paul.
The comment I have is gone on the voluntary participation and what that means and making sure we get the right balance. One of the central tenets of the EIM that's also in this mix was sort of the mutual exchange of transmission. So when I hear about some of these things, the mitigating bids, and that could affect flows and between balancing authorities, you get a situation where an EIM entity could be selfish. They want to take the benefits and then maybe prevent when maybe some of those benefits don't necessarily flow to them. And then also how that then voluntary nature of these interacts with CAISO, which does not have a voluntary nature. So what it means to be this whole issue of voluntary and how far we take this, I think needs to be given some thought. And that's pretty much all I wanted to say.
Okay, thanks, Paul. So with that, I'll move to the first proposal around the competitive LMP to address the flow reversal. So let's sort of walk through what actually causes flow reversal. So this is for an individual balancing authority, EIM balancing authority area. It becomes import constrained, and then we trigger market power mitigation for all resources within that balancing authority area. And this prevents the native imbalances for market power within that balancing authority area because we then replace with mitigated bids. Now, once those mitigated bids are put in place, they're not just required to serve native load. They could result in a change in the export quantity, and to the extent where it even goes from an import all the way to an export. Now, when it's done that, we see that the import constraint is no longer binding, so there actually isn't market power. And the only reason they're selling to the other BAAs is because the mitigated bids were used in the market. So to address this issue, we propose to calculate the competitive LMP for each market run. And this addresses the flow reversal because if you put in place the correct the competitive LMP, any resources within that balance, since when we calculate the competitive LMP, we would mitigate all resources within that balancing authority area to the higher of the competitive LMP or the resource's default energy bid. And so since prices are higher inside the balancing authority area than the competitive LMP outside the balancing authority area, you wouldn't see any economic displacement as a result of those mitigated bids. However, our current rules prevent the accurate use of this. So we need to eliminate some of the current rules that we have. So the first is the balance of the hour mitigation in the 15-minute market. We can calculate that each 15-minute interval. We also are going to propose to eliminate the rule that if you're mitigated in the 15-minute market, that you are automatically mitigated in the real-time dispatch. And then we also want to eliminate the rule that if in a 5-minute RTD run, you're mitigated, that we would maintain that mitigation through the balance of the 15-minute interval. So we'd be evaluating the calculating the competitive LMP for every market run. As I mentioned earlier, in the 15-minute market, that we get an accurate competitive LMP because we run market power mitigation. At the same time, we're running the binding FMM interval. But in RTD, there still can be a gap because we use the advisory interval for prior market run. And then the second change is to address concerns that you could have the dispatch order change even though you use the competitive LMP. So we're proposing to put a nominal parameter so that the bids will be mitigated to amount and make sure that it's a little bit higher than what the actual competitive LMP is so that you don't change the dispatch. And so again, that ensures that price separation between the competitive and non-competitive areas. So
we just want to not oversell that, Don, because your comment about, we got the advisory versus binding interval. So there still could be some flow reversal happening when conditions are different, but it'll be a lot better than what we have now. So it should address most of these, but we shouldn't overpromise that it'll never happen. And that might be a reason also to think about some of these other changes actually support it of not allowing mitigation beyond what's offered for flexibility and so forth could help support this goal as well.
No, I think when we were developing this proposal, that's the exact thinking that we went down. We haven't totally solved the problem, which is why you need the second one as well. But I think this addresses for the individual balancing authority areas problems, the biggest problem that we were seeing. So now when we look at how we currently mitigate using the competitive LMP, so again, we would use the competitive LMP, and it could only decrease if you were mitigated in a previous interval, and the mitigated bid was the max of the DEB or the competitive LMP. So what we're proposing to do now is, with these two changes, calculate the competitive LMP for each market interval, and then have the mitigated bid be the max of the DEB or the competitive LMP plus a small parameter necessary to ensure that price separation. So we do have some numerical examples that we showed here.
Don, before you go on, I think there's one other issue that we need to talk about, and that is if a unit is committed based on mitigation, and then becomes unmitigated later? Perhaps wind increases or solar increases so that you committed on one set of economics and it's mitigated, and then later on it no longer has market power, it's not mitigated. When you go to calculate the bid production cost guarantee, I think we need to think about how we calculate that. I'm inclined to think we should calculate the bid production cost guarantee based on the offer prices that were used when it was committed, even if it turns out later that those were, not mitigated later. So maybe it was mitigated when it was committed, economic based on those prices, and then later on it could be dispatched for energy, and it would be not mitigated in the dispatch. But I think if you go back and calculate the bid production cost guarantee, you ought to seriously consider calculating the bid production cost guarantee based on the offers that were used in the evaluation which was committed, to avoid, strategies of submitting bids that'll blow up when when mitigation comes off.
So I think one of the things we've been discussing internally is, we would want to run the dynamic competitive path assessment for every single interval in the 15-minute market, so that we can address that, so that we know that based upon what the information we have in this market run, we know that it'll be mitigated, not mitigated, not mitigated, not mitigated, for example, and then we can get the correct commitment decision with that information. But what you're saying is that once we've made that's good, we've got the correct commitment, that once we then, if things change, we go to the next run on it, and we thought it was going to be mitigated and it's not mitigated, that we would use the offer price instead of the cost, instead of the mitigated bid that we assumed when it was advisory?
No, I'm saying we should calculate the bid production cost based on the mitigated offers that were used in the run in which it was committed, which we did the economic commitment, and that maybe, if it turns out that wind soars, over the next 30 minutes and the unit doesn't need to be dispatched for energy, fine. Use its higher offer bid. Doesn't need to be dispatched for energy, but still use its original offer prices for
This is Brad, ISO. I believe under our CCW changes, where we have the separate commitment cost mitigation, I think that's the way it'll work under the CCW changes, but I'd have to double check.
Might be, but I'm just saying this is something we ought to make sure we understand how it's being handled.
Yeah. Mike.
Yeah, so in the thing that you guys were just talking about, I think what's true is, Scott, when under the CCDEB proposal, when the resource is committed, if it's committed based on mitigated commitment cost bids, those bids will be locked for the period of the minimum on time. And then, if the energy bids then aren't mitigated, then it's going to be dispatched on its unmitigated energy bids. And so if it doesn't get dispatched for energy, then it would only be getting BCR based on the mitigated commitment cost bids. So I think what I think you're describing, I believe, is already incorporated into CCW.
Okay, that's good. I just want to make sure. Yep.
Before we go on to the examples, any questions here, or operator, any questions online? Nope. Okay. Don, time to do the fun stuff. This is what I always like.
As you can see, we copied your format, Scott, so imitation is the biggest form of flattery. So here we have an example where we've got a single balancing authority area. We run the market power mitigation run. It becomes import constrained because we see that there's a 500 megawatt import at the 500 megawatt limit. And if we calculated the unmitigated price, it's $80 in this example. So if we then put in our rule that the mitigated price is the competitive LMP plus, in this example, we're just using $1. You can see that we don't have any change in the import quantity because the supply in BA1 is more expensive than outside the balancing authority area.
I've got a question here. So the 71, I'm wondering the mechanics of actually calculating that $71, especially if you have a network grid, it isn't a radial grid.
In this case, you just looked at the LMP in the area you're importing from, saying, it's $70, so that's the competitive LMP. Because literally, if you ran a version of the model, everybody at their DEBs, then the price would instead be $20. The competitive price would be $20 within BAA1, right? So I'm wondering how you know that $71, especially in a network.
Actually, I'm confused by that. So there's only 900 megawatts of supply at 20. If I'm reading this right.
Remember, how this works is
okay. So you're right.
But I am confused by this example. So
remember, all we do is it's all done by the way it is today, by setting the shadow price of the non-competitive constraint to zero. Because remember, the LMP at that location is the sum of the shift factor times the shadow prices. So all you do is set the shadow price of the non-competitive constraint to zero, and you've got what the price would be without that constraint binding. So that's what we do today.
Okay, so that shadow price is $10. So that subtracted from the $80 price in the market power run, you get 70. Add your epsilon to that of $1, and
yeah. Well, you don't even it might not be $10 at every location. The shift factor times the shadow price. Right. It would be whatever it would be. We know that number. The software all.
So in a gridded network, if you have two constraints, say binding coming in, you subtract both their shadow prices, and out it would come.
Right.
Okay.
Or even as an open interface with different impacts at every constraint and at every location. You'd just be setting that shadow price to zero, and you'd get what the price would be at every location without that constraint binding.
Okay. Don, is that your understanding?
That's correct. We do calculate this for each node in the system, the competitive LMP.
So can you just talk through what happens under the current approach? Because I guess I don't see flow reversal from this example.
That's what I'm with you. I don't see one. We didn't put in the flow reversal example. Because I would need to have more supply than 1,000 megawatts. So if I increase Gen A's supply to 1,000 megawatts, then you would see that occur.
Right. So even under the current rules, under example A, wouldn't the price be 70? It'd be 70, not 71, I guess.
Right.
And then would Gen A?
Because the right now we calculate that 70. So we might have a price that's $35 because it was calculated at the beginning of the hour. Unfortunately, now the sun has gone down, so the price is much higher, and we get a big change in the dispatch because we're using a price for the first 15 minutes of the hour and the last 15 minutes of the hour.
Okay, so Scott was saying that the competitive LMP could be a lot lower. So there's a couple things going on here. One is sort of the interval by interval dynamics, which isn't really captured here. But yeah, so that would be the competitive LMP on the other side of the constraint might be 35 instead of 70, and this is able to at least capture the changes in on the other side of the constraint.
If it's higher, though, right?
But I guess, when you stare at this example, one thing that comes out is that if you actually believe these DEBs, you still have Gen A generating a lot less energy than this so-called efficient dispatch would. But I guess that's sort of something that just comes out of applying the competitive LMP as a floor in any kind of context. So that's just a principle that... okay, but I guess I struggled with seeing where there was how this was flow reversal.
We can construct this one to be flow reversal. Yeah. Make Gen A's Cmax 1,500.
Oh, okay, yeah.
So now at 1,500, if we actually mitigated it to $20, it would then move. It would then become. It'd be more. You would want to export as much of that out of that up to the 500 megawatt limit because the 20 is less than the competitive LMP.
Right. Okay. So if it was 1,500, then you would be forced to export. Yep. Okay. I see it.
And as Scott pointed out, if you don't have the correct competitive LMP, this then becomes a very likely scenario to happen.
Yes, and the competitive LMP from the previous interval was
35, then
30 or something. Yeah. But we're not.
Yeah, if we just try an interval, it probably wouldn't happen. But today, it could be from a long time before. It could be the.
Yeah.
Hi, Steve Keeney, Navigant. The one thing, and I see with this, you've mitigated the price to 71 in that area, but you still have essentially congestion, the same thing that triggered the market power mitigation in the first place, the fact that you were hitting the limit on that import, that's still there.
Correct, and that's what using the correct competitive LMP gets you, so that you don't actually you don't change it. So now it's exporting, or that constraint's not binding. So how could you say you triggered mitigation for it?
I guess what I'm saying, though, the way you do it now, if you went to the competitive price to $70, then presumably, depending on how the LMP system would solve out, that it would release the congestion on that import line. You'd probably pick up $70 from one of the mitigated units inside, and you wouldn't be seeing the congestion anymore.
Well, I think the key is that's why we wanted to put the small adder, is so that you don't have that where you basically have two offers at $70 and the software can have an infinite number of solutions that it could come up with. So we wanted to make sure that we kept when there is congestion, we kept the competitive and the non-competitive areas separated by that small adder. Mike.
It's Mike Castellano, DMM. So just going off of what Steve just said, I think what we're really doing here, we're not talking about stopping flow reversal. We're talking about preserving the flows from the MPM run. Because another thing that stops flow reversal, technically, if we're using the competitive LMP from each interval, so we don't have like Scott's example where, 45 minutes ago the competitive LMP was $35, we mitigated something and we've kept that mitigated price. So if we have that $70 competitive LMP, if Gen A is 1,500 megawatts and we mitigate them to $70, we shouldn't get flow reversal. What we would get then is Gen A getting dispatched up to relieve the congestion on that constraint. We still have a transfer cost to put the power, to displace the $70 power in, I'll just call it CAISO because that's how we usually refer to these scenarios. To displace that $70 power in CAISO, there's still I forget what it is, a tenth or a hundredth of a cent cost on every one of those megawatts to flow back. So what we would really be doing is this would allow BAA1 to continue to buy from outside instead of having to satisfy their own load.
Correct, and we would then mitigate and change the dispatch potentially. Actually, we wouldn't necessarily change the dispatch because we used that competitive LMP with the small M.
You might or might not. It depends on what the offer is. You could change the dispatch around in the BAA, or you might not. You might just change the price. Yeah.
But I think that's the key. By having the right competitive LMP between the outside and inside the BAA, then you basically isolated that redispatch to that balancing authority area. And if you think about the EIM entities, if they saw that there had for some long-term reliability reason that they didn't like the way the dispatch came out, then you could manually dispatch that and preserve that. But the key is this is now all completely isolated in terms of the redispatch to serving the load within that BAA.
So, what I've been trying to figure out is if there's a scenario in which, say, somebody in BAA1, if the generation parameters played out that way, that the price should be below 70 and constrained out, I guess. And whether there's a scenario in which by raising prices internally you're successfully able to raise prices from what should be a lower BAA price to a system-wide price.
I mean, that's not local market power. That's why we're not mitigating. That's the basic philosophical thing.
Yeah.
There's no congestion, and they're competing with everybody in the EIM, or at least all the supply in the CAISO. We shouldn't second-guess their offer prices, because especially with all this hydro, the odds are we're going to screw something up. So we're only going to mitigate when there's local market power.
Yeah, I understand that perspective, and maybe that's just sort of another example of how this approach to local market power mitigation. But my question is...
That's what we do in the CAISO, too.
Yeah. But if this were a scenario in which it actually, the mitigated bids resulted in congestion out and a lower price than 70 within BAA1, wouldn't the floor bid then be the mitigated lower price within BAA1 still?
You wouldn't trigger market power mitigation within that balancing authority area because it's
congested out. Okay, but this is we still have the same unmitigated circumstance where it's congested in. So you do the run, but then after the run, with the mitigated prices, you get congested out. And so I guess I'm confused as to what the mitigated competitive price is under that scenario. You're saying it would still be 70.
That we wouldn't mitigate it down to 0. We mitigate it down to 70, and we wouldn't have congestion out.
Because we just get rid of the shadow price. It's not like we're redispatching at all of those bid prices. Right. Okay.
What's the pharmacy? I think in this example maybe makes sense to me, but it's very difficult for me to understand when you put into the local market power mitigation, because local market power mitigation is based on the constraint, and you're saying the mitigated price should be different between the constrained area and non-constrained or competitive area versus a non-competitive area. I think within the network, I guess you couldn't. How do you define the competitive area versus non-competitive area? Because everything is based on the constraints. One area could be competitive per constraint A, and then could be non-competitive for constraint B. Does it make sense?
So again, you're calculating that competitive LMP for every single one of these generators. So that to the extent that they had different flow impacts on other constraints, then they could have different competitive LMPs. We just showed one to make this example simple, but you actually calculate the same one for each generator.
Yeah, but what I'm saying is generators, say A through C, in the network could be in a competitive area for constraint 1 and could be in a non-competitive area for constraint 2. So I think maybe I can clarify. The mitigated price you're saying for the BA1, is that mitigated price $71? Is just price for that BA1, or is it applied to all the resource in that area?
So again, you would calculate the competitive LMP individually for each generator, and then whatever became the marginal resource using those competitive LMPs would set the price in that balancing authority area.
Okay, maybe I should ask a different question. So that 500 megawatts limit is import limit to the BA1. So I think that limit will isolate BA1 from the competitive area. I think from that perspective, it makes sense. However, if that 500 megawatt limit is, say, just a thermal limit on the transmission line inside a network area, how do you define it? I think that limit doesn't necessarily isolate the whole area from the rest of the grid. It could be a network.
Yeah, but that's not Brad. So that's not the situation we're addressing here. What we're addressing are EIM transfer constraints.
Okay, so
it also works for individual constraints. I mean, that's the way it works. You still have a shift factor times a shadow price for every location, and it's for the non-competitive constraint. So you can set the shadow price of the non-competitive constraint to 0 for every location, and and you know what the congestion component is for every location, which is constrained up and which is constrained down relative to that non-competitive constraint, just by the sign convention. That's what we do today.
Yeah, but that non-competitive, the competitive LMP would be different for each unit.
Right, it would be. It would be. When you set that shadow price to zero, you could potentially get different competitive LMPs at every location because of other competitive constraints, and the amount you'd be reducing the price would be different because that non-competitive constraint could have a different impact on the price at every location.
So that's just based on the competitive LMP components of the prices for all.
Right, the competitive LMP would be replaced, determine the offer prices, and then you dispatch the system based on those. So if you had multiple competitive LMPs at all those locations, it would.
Yeah, but I think the dispatch decision will be based on the total LMP, not just the competitive LMPs. I mean, the flow.
But the competitive LMP is what we're using to replace the offer price. We'd be minimizing the overall cost of load, but we'll be using the competitive LMP as the mitigated offer price.
Okay. Got it. Thank you.
Jim, just to kind of follow up on the comment you had, the thought process you were going through just a minute ago. This is Gabe from the ISO Policy Department. You can have situations like that when you have imports from a second BAA area, and those are lower priced and those are binding into the first BAA area, where this one would generate out and push energy back to the ISO. But maybe we don't want to go down that rabbit hole too far.
So I think with that, since these other examples just are pretty minor, we should just move to the when the two BAAs scenario. So the way that the market power mitigation works in the EIM, when there's two or more EIM balancing authority areas that become in-court constrained into their bubble, then we trigger mitigation and mitigate all of the bids in that both the balancing authority areas. And once you do that, you can result in additional economic displacement because now the transfers would change because we're using mitigated bids and not using offer prices. And this can result in an increase in exports than what was shown in the market power mitigation between the two resources. So we're proposing to put a limit on the amount of that transfers. In the paper we talked about whether you need to look at both the export and the import. I think upon further reflection, if you just have this as an export rule, you actually get both of those scenarios covered.
Don, go ahead, Scott.
A couple of people have said they think that the fix, changing the offer prices is the worst option, and fixing the exports is the good one. I'm in the reverse. I'm very concerned you're going to get a lot of unintended consequences from this. And for one thing, let's think about the fact that we've got this time separation. We're going to be running we're going to be basing the mitigation on the advisory interval.
In RTD.
And then we're going to have the real world happening. So suppose that this, if you go to one of your pictures where BAA2 gets the interchange frozen, well, suppose that you forecasted 500 megawatts of wind in the advisory interval, but the wind goes down to 250. You've now completely screwed BAA2 because it can't import any, if the constraint was non-binding, this one has a binding constraint, but in the case where it's non-binding, you've denied BAA2 the benefits of the EIM. Its wind goes down and now it can't import anything in order to deal with that. And I think when you've got this lag, we've got some unintended impacts there in terms of how this is going to shake out.
No, and I think if we look through these examples, I think what you see is that let's say that I only put in sufficient transfer capability for me to fully capture my diversity benefits. Then you would see an example where that would become binding, and we see those results. If you look at the example when we go through this, what we show is that if you then limited the transfers to that amount, you basically get the same settlement of it, but you haven't mitigated above and beyond what they needed to pass the resource efficiency test. And I think that goes away to addressing your RTD problem, because to the extent that it wasn't, the advisory interval had a transfer less than that amount, that you could then increase that transfer in the binding RTD interval. But you could argue that if you'd already used it all up in all up, yes, the economic displacement would help, but that's what we're trying to...
Yeah, but we don't know that you've used it up. It seems to me fixing the flows, you could fix the flows at 8 megawatts. And then the optimal dispatch is much higher. If you fixed it at the amount sufficient to accommodate
or the higher of
the flexible capacity, but that's complicated too when we have all these different BAAs and certain patterns about how they be nested within each other. I think that could get very complicated as well.
I was going to actually ask something related to the complexity when they're nested each other or the network. So if it's not a radial system, if there are multiple ways that power can get in, how do you decide that a pair of BAAs are import constrained? There might be one constraint but not another one, and you can redispatch to get more power in if you want, but at a high cost. Is there an unambiguous way to decide in that circumstance, yes, it's import constrained or not? In case of a network and multiple ways you can get power in.
Well, so again, we're looking at the transfer limits into these balancing authority areas. So the key is we maximize the transfer limits into the balancing authority area, and then that's what triggers the fact that we will now have mitigation completely in both balancing authority areas. So it's that transfer limit constraint that's triggering this.
Okay, so it's not line constraints on the linearized DC network, which might be very complex, but there's an overall megawatt transfer constraint, and that's whether or not that's binding will trigger it.
Well, technically, isn't it? It's the power balance constraint is what triggers it, right?
How's that?
Mike, did you want to add
a violation? No.
So what happens basically is, you could have a BAA that actually has no imports or exports being essentially import constrained, because what you end up doing, the way the math works out is, we have an assumption that the California ISO BAA essentially is competitive, right? So whenever you're separated from that ISO competitive price, you're considered essentially import constrained. So if, like, say in this radial BAA situation, if BAA1 is separated, if that transfer from, the outside to BAA1 is full, but there's no transfers between BAA1 and BAA2, then at that point the power balance constraints on BAA1 and BAA2 are going to reflect the fact that serving a marginal megawatt of load in either of those BAAs is going to be more expensive than serving a marginal megawatt in this sort of outside competitive area. So those power balance constraints will have positive shadow prices, and that's what marks, what we probably not so precisely call import congestion into an EIM BAA.
The power balance constraints will have different ones. Now, in a network with a lot, linearized DC network with a lot of potential constraints, you can have two power balances in two areas having different prices, but, maybe because of some constrained line way out here. And you could get more power from the KISO to the other one, but you would have to redispatch, and that's why the prices are different. So in a pure radial system, very intuitive, we can understand how that works, but in a network, so go back to Don's point, are you saying that it's not just the inter-BA transfer constraints, whether they're binding or not, but it could also be network constraints on the system, anything that results in a different shadow price from two power balances? Is that?
Yeah.
So you could get a $1 difference because of some 115 or 230 kV line way off somewhere. And you could really get more power in there. It just costs you.
No. So I think the way, if there were, say there's a 230 kV line somewhere in Utah and that's impacting prices at a bunch of places, that is not going to do the same thing because, the way there could be mitigation because of that line, but that'll be mitigation because of that line. So I think that would be considered a little bit differently. The way we generally look at this, I think, is just when those when any sort of interface between a set of BAAs and the larger competitive area becomes congested, then that set of BAAs is going to have higher prices potentially based on serving their internal load within that group. So that's not necessarily going to be. I don't think that would have anything to do with a local constraint.
Okay, so it sounds like Don's logic, that the interface on the inner BA flows has to be congested, and you see a difference in the power balance prices for the two areas, then you trigger it. But if it's not congested, you might have a difference because of this Utah 230 kV line, but you don't mitigate that.
And that would not be mitigated then? I thought. Because I guess I was following this discussion as sort of a big level, same idea as LMP, that to get it from California to, say, Arizona, it may be physically possible, but you have to do some redispatch up in the Northwest in order to actually do it, that would cause the prices to separate. And I thought Mike's answer sort of said that would create two different power balance values, and therefore that would be considered import constrained at that point.
Isn't it that we mitigate for constrained transfers based on the shadow price of the power balance constraint, but for internal congestion, it still works in an EIM area. It still works the same way as internally in the ISO.
Yeah, that's true. I'm getting a little lost on what the question is now. So we were talking about price separation, or we were talking about what constitutes import congestion and whether one BAA is considered import congested. What makes a BAA considered import congested? So remember, the EIM transfers are not flow-based constraints; they're scheduling limits. So every generator, it's a scheduling limit that it sits at the distributed generation aggregation point, I think, of the EIM BAA. So every generator essentially has a shift factor of 1 to that limit. So 1 to the EIM power balance constraint and everything related to transfers. So those transfers automatically, the transfers in the PBCs sort of separate the whole BAA as a whole. If there's separate internal congestion somewhere, then that's subject to all the same measures of potential mitigation that any physical congestion on a line within the CAISO or anywhere else is.
Okay, so to really understand this, we'd need to look at the math, and we definitely don't want to do that here. So I'll leave this to an offline discussion, and hopefully that'll result in me understanding what's going on.
Okay, so do we want to go through the specific examples in more detail, or do we want to move to the next topic given where we are on time?
We're about halfway through the agenda item time-wise, and you're about halfway through the slide.
Yeah.
I did have a question about this slide.
Okay.
And so it might be good to at least skim off that. So this is a funny example because there's degeneracy, so there are multiple possible prices. So if the limit was 501 megawatts on the left, then the price would be 80 in BAA1 and not 90. If it was 501 megawatts on the right instead, the price would be 90 as it's shown here. I'm wondering if this, I guess if it was 501 megawatts on the left, it wouldn't be let's see. You would then have would still have a, would we then consider this as two bubbles? Let's see, what would happen?
So I think what you've got one, where BAA2 is import constrained within the bubble, and the combined are import constrained from the external area.
Yeah.
So
they're both okay. Yeah, they're both constrained. And with 501 on the left, they would still be both constrained, but now we would have different prices in BAA1 and BAA2.
You mean a 499 limit?
499. Well, let's see.
501 would make it less.
501, you would then be. You would have. I'm sorry. You would have $70. Right. If it was 501, you would have $70 BA1. It would no longer have price separation. You're right. Yeah, that's what I wanted to say. The LP, the linear program, could give either of those prices. Could either give 90 or 70 at this point. So if you epsilon perturb the transmission constraint, you get one of those two prices. So if that, okay, Scott taking your...
So I think the key is if you needed to serve one more megawatt of load in BAA1, you wouldn't want to export it to BAA2. That's why you get the same price in both BAs.
Let's see. Maybe can we work through what Scott just said? So 499 megawatts, $70 on the left, 499, you import that. Generator A would be then basic. Generator A would be generating 499. The price would be 80 in BAA1. The limit between BAA1 and BAA2 would be binding, and so the price would be still higher in BAA2. So you'd have prices 70, 80, and 90. So we have a bubble within a bubble. Is that a problem? Or does that cause...
I don't think that causes a problem. I think we're just...
Yeah, because remember, we're just setting shadow prices and non-competitive interfaces.
Okay, so that doesn't...
How many we got to set to zero?
Okay, all right.
So that's what we show in the mitigated approach, that now you see that separation.
Okay, question.
Can you go back to the previous one? Okay, I can see where the 90 is coming from, because if you increase load in BAA2, you have to do 90. But...
Or BAA1, because they're out of Gen A's limit. Right at a razor's edge.
Right. But you've got 500 megawatts from Gen B that's at a zero price.
But it's maxed out. The thing is, we've got a knife edge equilibrium here, because Gen A is completely dispatched and Gen B is completely dispatched, so the...
Gen C is the next marginal generator.
If you go up. Yeah. If you back off, it'll be A.
If you didn't have D, it'd be C at 100. Margin for both balancing areas.
Okay.
But it's right there
at the edge.
Right. And if we make... If Gen A was actually a 600 megawatt unit...
Right, then it would be different.
Then it would be 80. Yeah. Then we'd have, in my case, 70, 80, 90.
Yeah.
All right.
Okay, and so then what this example shows is that given that both constraints are both the import constraint from BA1 to BA2 is binding and the import constraint into the combined area is binding, that you do see price separation within the bubble, and you have different mitigated prices as a result. So now we move to the example where there's unmitigated, the transfer limit isn't binding.
Don, can you back up? So we have an interesting situation where this is a radial network, but we have flow. Okay, no, this is correct. Never mind. I'm okay with this. Go ahead.
Okay. So in the next example, now we walk through and show that the price that the internal transfer limit between BA1 and BA2 is not binding between the two balancing authority areas.
Right, it's 1,000.
Okay, but the fact that we've now are import constrained to the combined area, we do trigger mitigation of all the resources in the balancing authority area, and then they're mitigated again to the higher of their DEB or the competitive LMP. So in this example, what we see is that the transfer actually increases because Gen D's DEB is higher than the competitive LMP. And so what we do is we dispatch down Gen D and have an additional 200 megawatts come from Gen C, who's now using their mitigated, the $71 competitive LMP. So this is the issue where we've now increased the transfer quantity and had redispatch in both balancing authority areas, which result in a higher transfer than what was done in the unmitigated run. Now, if we had put in place our rule that you limited it to the amount that occurred in the unmitigated run, or the let's assume that that's the same as that's also the amount that you need to pass your resource sufficiency test from a diversity benefit, you see that you actually get the same price as you do in the original example where they only put in place the 500 megawatt transfer capability.
The problem is that the megawatts here, the megawatt flow can 7,500, it could be 0. It could even be exporting from BAA2 in the unmitigated dispatch, but then in real time, BAA2's net load goes up 300 megawatts. We wouldn't want to freeze them so that they had to be exporting or not able to import.
I think you want a rule where you can't have incremental exports, but you could allow decremental to the extent that it was economic to get it.
Well, but I mean, suppose the imports were 0, and BAA2, because in the base case you didn't need imports, or suppose there were 5 megawatts of exports. BAA2 put in their flexible capacity, and then they need it in the binding interval because the wind died. We'd be locking them out from getting any supply from outside the balancing area, maybe causing a power balance violation. It's completely spurious because we actually have 490 megawatts of transfer capability.
And I think this is exactly the reason why having the simple rule that we put out in the issue paper, where you just hold it to the market power mitigation run, is too simple of a rule. And you need to do something like put in the amount of the diversity benefit. And so at least then, if BA2 needs it, they can get the amount of the diversity benefit. If they need more than the diversity benefit, well, they shouldn't have counted on that supply from everybody else anyways.
Right.
So I do think that this proposal needs to be enhanced to address that concern. And I think that you have to have something like that put in place, especially given that we know that the competitive LMP out of the RTD runs can be wrong.
And just the net load can change, and this is very sensitive to that. And it's that net load change. It's one of the benefits of the EIM that they can get things adjusted much faster than outside the EIM.
Mike.
Yeah. So there's another thing about this that concerns me, and that's that essentially we're establishing the transfers based on a sort of a gradient of prices from the MPM run, and then we're potentially changing the prices and changing the gradient of prices in the market run. So I think if we look at this example, just imagine we switch the places of generator C and generator F, and everything else stays the same. I think what you get is you still get the same transfers, but then in the market run, BAA1 would be priced at $90 and BAA2 would be priced at $71. And so you have that 500 megawatt transfer from a $90 area flowing to a $71 area, which doesn't seem efficient.
So, Mike, I think that would be a good example for us to walk through on the workshop that we're going to hold on this, and see if we can construct those.
Okay. This is Brad. I'm just kind of thinking out loud. This does kind of point to maybe the approach is what Mark Holman was suggesting is limit the quantity of bids that you mitigate rather than limit to transfers. Because even if we limit them, not freeze them at the market power mitigation run, but allow them to increase by the amount of the diversity benefit, that still leaves the other BA, in Scott's situation, the wind dies in BAA2, that still leaves BAA2 short, and they might...
But at least get it the amount that's entitled to under the diversity benefit. But the thing is, it becomes a hard constraint. So suppose that you offered 300 megawatts at the mitigated price but you also had some other that you're willing to sell at 200. Well, actually, BAA would be willing to pay 200 for it. Now you're saying, no.
They might have been willing to buy it at the unmitigated price.
Right. Even the price, even with some market power, is better than just cutting off trade altogether.
Yeah.
It might not.
So, have you had any thought in terms of how you could try to address that? Do you not, when there's mitigation, do you step it, for example, put a lower relaxation on it to where you let those flows go in, like $200, $300 or something?
Well, we were talking through, when Mark was on the phone earlier, we were suggesting, well, maybe we apply mitigation to the resources supporting the base schedules and the amount of flexible capacity they're required to offer, but anything they put in the market above that, we don't mitigate. It's not, even that's easier said than done because we actually don't know what their net load is. So there's all of these things are very complicated, but that's, that would be a concept to see if there was some way to make it work.
Okay. We haven't gone to the phones in a while. Is there anybody? Okay. Thanks. All right. Okay. So good discussion on these two items. So now I think we'll move to the market power mitigation stuff, and I've got others to help me on this one. So we still now will have instances where the resources are mitigated for either the diversity benefit portion to another balancing authority area or within their balancing authority area, and to the extent that it's not accurately reflecting their full opportunity costs, we would want to provide an additional option within our options of default energy bids. So currently, in terms of what we're developing as part of CCE3, our opportunity cost methodology does not consider whether or not that there's other trades outside of the EIM. And so it also doesn't consider whether there's limitations that occur within the operating day. And so we're proposing for these EIM use limited resources that we would allow them to recognize that over a period of time they have opportunities to sell outside of the EIM and try to reflect that within their opportunity cost and reflect that within their default energy bids. So the approach would be you would compare take the higher of the day ahead index, the month ahead index relevant for the amount, for the duration in which they're storing their capability. And then if they could store it for 6 months, then you'd have 6 month ahead indexes. If they could store for up 12 months, they could have 12. And then you would take the higher of those as a proxy for what the opportunity cost is to sell over that horizon. It doesn't reflect that there may be, the month ahead indexes for all hours. It doesn't reflect that there may be higher priced hours within that month, or you only take the highest, you don't sell in the belly of the duck. And so it's not getting at that, but it's getting at an approach to where at least we're recognizing that there is the ability to sell outside the EIM and using these monthly prices. I got one.
Go ahead through that.
One more on this one. So then, similar to our other default energy bids, then you would have you would do that calculation from the previous slide, and then you would give an adder of 10%. And the reason why you only go to a 10% versus a higher adder on that is because, again, we only trigger mitigation if there's actually uncompetitiveness. So we do that dynamic competitive path assessment. So only in the intervals where there's market power. And that we've showed that performed some analysis that we're not going to review today that shows that the 110% would still preserve that use limited resource for the highest value. And then lastly, the additional changes that we're proposing with regards to the reference level adjustments does allow, to the extent when we saw real-time electricity and energy prices spike, they could come in and ask for an adjustment. So if it was higher, the prices to sell in real time were higher than the day-ahead price or any of the monthly indexes, they could then update that, and that would be reflected in their DEBs in the real-time market. So that's the summary of that proposal. I know, Scott, we've had some discussions with you in terms of what does the duration really mean? You know, are we talking about how long they can discharge for, or are we talking about how long they can hold it for an opportunity in the future? And we need to be really precise in terms of setting that when coming up and using this approach.
Yeah, the kind of concern I have is if you've only got 30 hours of water in your reservoir, you may need to use that in the highest valued 30 hours the next month, which might be much higher than this. But on the other hand, if you have 200,000 megawatt hours of water in that, you're going to have to use it in, you know, down to the 50th percentile of the hours in the month. And this concept here is a little, I don't know, I think it needs a lot more specificity of how it's going to work to get there. I mean, that's why some of the other ISOs use this historical LMP of, okay, you've been releasing water at a marginal price of $50 for the last 9 months. Don't tell me today that when it happens to be hot in Georgia that the price is $500 when you've been releasing it for $50 for the last 6 months. You know, they go back and look at what's the marginal LMP when you were releasing water historically. And that, you know, that would seem to provide a better indication than this. Index is here, isn't it? We look back at the historical offer prices when they release their.
So I believe that's the approach that's being implemented as part of CCE3, to where we would calculate the opportunity cost and based on the duration and their dispatch levels. I think the concern.
Sorry, I didn't mean that. No.
Go ahead, Eric.
Well, to correct the record, no, the approach that was incorporated in the MRTU tariff is not like the LMP approach is not like the Eastern ISOs. It takes the lowest quartile of the prices when you were dispatched. In that, I mean, it takes the lowest quartile. So we've, yeah. Okay, then we have that in the tariff. So we have what Scott's pointing out in the tariff. And I would just point out, too, the other approach, the unit with the 30 hours for the next month, that is something we offer under the negotiated DEB option today. So, because that has to be customized, you know, but if they have 30, you know, if their forecasted energy is 30 hours, we would take the next, you know, we would come up with a hourly or 15-minute price curve for the next month, and then take the strike price, you know, the optimal strike price. So we do have an option for Scott's example, but it's not one of the, it's a standard negotiated option.
This is Callie Wells for WPTF, not to add to the complexity, but what's going into place is based on forecasted LMPs compared to their cost, and it does, to Scott's previous point of, are we talking 12 months worth of storage, or I can only generate, 300 megawatt hours. It's the 300 megawatt hours that's going into place soon. So there's some differences here between what's being proposed for EIM hydro versus what's going to be available to all other hydro resources.
Are there any questions or comments on the phone?
Yes, we have one question in queue. Caller, your line has been unmuted. Please state your name and your question.
Yes, good morning. It's Mark Holman with PowerX. I think this one's worth a really good discussion, and I think both about the historical approach and what's proposed here. Maybe start just with Scott's point, which I think is very valid, is that when you look at, what is the storage horizon? You can have a small reservoir with really low inflows, and you've got, say, 30 hours of water, worth of water, but you can use that anytime over the next 3 months before inflows start to pick up again. So that could be a significant time horizon. You can have a very large reservoir, as we rely on, where that large reservoir has significant inflows, but the reservoir is so big that it can store those inflows over the course of a year without generation. On the flip side, you could have a fairly large reservoir that has such huge inflows that it almost kind of run of the river. It doesn't have very much practical storage at all. So that is a challenge. But I think the first point we need to understand here is that we're not going to be able to get an accurate marginal opportunity cost for external hydro. And we've gone through this extensively, that the inflows change, there's interdependencies between the different resources in the BA, and what's available for future market opportunities is residual. So what are the future inflows going to be? How much of that is needed to serve load after other resources run and serve load in that BAA? So really recognizing first that we're not going to be able to accurately determine all of the future bilateral market opportunities for each hour over the storage horizon, how much water can forecast to be available that is residual for market sales, and what are all the constraints that apply to that. And so, what is the best way to come up with a good proxy or a good approach that does a reasonably good job given the information we have? And so maybe we'll start with, if you look at a resource, you say, okay, I've determined that the maximum horizon that water might be stored is, let's say, a year for this resource. We know that that they may have a constraint where they have to sell that water in the next 3 months, maybe it's over the next year, and we don't know exactly whether they're going to have a month's worth of water that is surplus to serving their load, or 3 months or 5 months. Well, what we do know is we know what the day-ahead price is. We know what the monthly on-peak price is for that maximum storage horizon. We don't know what the individual hourly prices are. So we don't know what the prices are going to be in the morning and evening peak versus the belly of the dock. And what those hydro resources are able to do efficiently is they're able to take their limited water, look at their maximum storage horizon, and sell it in the best hours on the best days in the best months. But we don't have forward prices, for example, for a 12-month resource of 87, 60 hours. All we have is the average price for on-peak and off-peak in the forward curve for each individual month. And so I think what the CAISO is proposing here, whatever that multiplier is, put that aside for a moment, is to say, we know the day-ahead on-peak price. If that day is really high, we're assuming that an entity would reasonably sell really hard on that day until they hit a constraint. And so the day-ahead on-peak is probably the relevant price. If the day-ahead on-peak price on that day is low, they're going to rationally save their water, try not to sell, and they're going to sell over their forward storage horizon. And they're going to do so in the best hours on the best days in the best months. Maybe they have 3 months worth of water to sell over a 12-month horizon. But they're not going to sell the best 3 months every hour, Monday through Saturday on peak. They're going to sell the best hours on the best days over 12 months for 3 months worth of water. And so I think, the unfortunate reality here is we're going to have to come up with something. I think the CAISO is taking a very reasonable approach by saying, let's try to determine the maximum horizon. And if the maximum horizon that water might be stored is 12 months, then we look at the next 12 months and we take the highest monthly price, recognizing that, A, maybe they have to sell 3 months worth of water, so that giving them the best month is too generous, but recognizing on the flip side that they don't need to sell all hours in a month, or even, that price reflects the average price in that month and on peak. They're going to sell the best hours over that whole 12-month horizon. So I'll pause there, but I think we need to recognize that we're not going to have information that's going to be able to determine an accurate default energy bid. So what is the best approach with the information we do have?
So this is Ben. So I have to, as I've said before, and I entirely agree with Mark that hydro operations are very complex, and it's very hard to determine what the marginal value of water is without a very sophisticated stochastic model that considers the cascading and so forth. And these models exist, but we're not going to be doing that or auditing them here at the ISO. And I agree with Mark's point that taking the very maximum will be generous, but maybe overly generous, maybe a term that some people won't like. If you have 3 months of water and use the very highest of 12 months, then it really should be some other period. But a point I wanted to make in determining how many months of storage you have, it's not necessarily storage divided by flow. What often happens in some systems is basically when you fill up the reservoir and start spilling, that's your horizon, and you're looking at the time until then. And not every year does that happen. I imagine that at least Power X system that they're, in a dry year you might not have any spill, in which case the horizon is, there's a chance that the horizon is well beyond 12 months. But this is, one thing to consider in figuring out the time horizon is that, for example, if you are in January, and you generally spill in the spring, the time horizon can't be any more than 4 or 5 months. After then, the water is zero value because you're spilling. Whereas if it's September or August, it might be 9 months. So this length of time, what this N was in the formula, will depend on which month of the year, because the number of months until when you expect to start spilling will depend on whether it's September or January. So that's something to consider in determining the time horizon for.
Is there a specific proposal for how N is to be set, or is that still a conceptual thing that you're working through? The N in the formula here, number of months of storage capacity, I guess it's the previous slide.
Yeah, Ben, this is Gabe Berthoff over here again. What we were thinking about is sort of the lower of those numbers that Ben was just describing, and we were also thinking about, and we put this in the paper, bounding it from below at 1. So, if you were a useless resource that had very little storage, like a run of river or something, you'd still get the maximum of the month-ahead price and the day-ahead price plus the 10% adder, but you wouldn't go any lower than that. And then you'd sort of have an upper bound on 12 months. So we look at 12 futures months and beyond that.
And so it could vary from month to month then as well. This would be dynamic in the sense that you don't set it and it applies every month.
This would vary on a daily basis. So we actually get monthly futures prices on a daily basis, and those are updated on weekdays when these packages are traded.
Well, the bid price would change. I think Ben was asking if how frequently N would be updated.
Yeah, this is something that we envision as a new field that would be in master file. So I think resources are permitted to go and adjust master file characteristics. We were also envisioning, again, in a proposal format here, that this would be something that would be like an estimated number for a typical hydro season, not necessarily a dry season or a wet season, but maybe a typical number. But again, that's sort of a working proposal hypothesis right now.
But I think in the scenarios you brought up, Ben, that I think you would want to have some ability for the duration to be updated on a monthly basis based upon.
Yeah, you can imagine it's a really bad snow season and you're anticipating a hot summer, that suddenly the opportunity cost in the summer becomes relevant, whereas most years it wouldn't be because you'd be spilling sometime in the late spring. So an ability to update that, and then for DMM or whomever to sort of check and audit that would be a good thing.
And yeah, I think we'd agree with that, and that's sort of one of the reasons why we wanted to have this as a master file parameter, so resources could go in and make those changes if they thought they were appropriate.
But again, I think you could even look at it as it's something that's you get to set monthly. It's not something you're setting every 5 to 10 business days. But that's all open for discussion.
Yeah.
Callie. It's Callie Wesley. I'm with WPTF. So hydro resources today can update their limitation. I'm going to look to DMM on how frequently they actually do, but those with negotiated DEBs for an opportunity cost have the ability to do that today. So that could be one consideration. I don't believe there's a time whenever and they can initiate that, I believe, whenever their limitation changes. I mean, what's the D&M on that one?
Those depend on the particularly agreed negotiated default energy bids. Those depend on the actual negotiated default energy bid formula, which is particular to each resource. But yes, they can submit new limitations within a month, for example.
So as part of this discussion, I've been wondering what the role of would negotiated options still exist then? Because it does sort of, now we're creating kind of a general formula, and Scott kind of characterized like certain types of units may be favored by that and others might be disadvantaged by it, but it seems like we're going to push the disadvantaged ones into negotiation while maybe the advantaged ones are going to be quite happy with the formula, and I don't know how worried.
Yeah, I think the fifth option, Deb, that we've sort of outlined here would be an additional option, just like the cost-based or the LMP-based option that a resource could select, and certainly there might be some that would benefit from having this. But the idea is still that this is sort of a more general formula that, an EIM hydro resource might choose to pursue, but then if they wanted something technical where they could actually enter in, even on a very frequent basis, how much storage they had, and they wanted to look at forward futures prices in their market or something, maybe they would go down a negotiated route if it's something more complicated than just simply using the month ahead and the day ahead prices from an index.
Do we have any comments on the phone? Okay, I think we're ready to proceed.
So the last element of this is the ability to update the reference levels. This recognizes that the information that comes in between the day ahead and real-time market may change, and that you could get new information, and so then we would want to reflect that in their bids, or in their default energy bids. And so again, we would allow that to be updated prior to the market. So with regards to gas resources, so they could come in and recognize and identify that their gas prices have gone significantly higher than what their current default energy bids consider. And then they could present that information to the ISO, and then we would manually update the reference level to the extent that it exceeded the automated reasonableness threshold. I think that's about it. So this is on the gas side, and then we'd want to have a similar approach that we could do for the use-limited resources, and this is to address in the formula that we just walked through for the new default energy bid option, that you would need to show that there's an ability to sell at higher prices than the day-ahead peak in real time, and then we would use that to update that formula.
So this is Brad. I'd just add that that's, in the case that the day-ahead peak index, something happened in the electric market and the day-ahead peak index was very low and prices exploded the next day, then we would provide market participants the ability to then request an adjustment to their reference level based on the formula to reflect the higher energy prices that day.
Any comments, my colleagues or people in the room? Yes, Wei. Please.
Wei from MSC. Just a quick question. I think the reference level adjustment, you put a max there. I think you're going to consider the volatility of the gas prices and the bilateral prices in terms of the significant increase in these prices. So wondering what your thoughts are on if the price is going to decrease or drop back to the normal level during the day. What you're going to consider adjustment to reflect that type of condition?
So we're not anticipating that we would take that information if there was a volatility and prices dropped significantly from what was assumed in the DEB. We weren't looking to to do that side of the equation. We're just trying to protect when there's large increases in the cost such that the DEB now is not reflective of what their actual costs were going to be. And I would expect that if the prices dropped for gas, for example, that you would see the profit maximizing behavior of the resource would then to be bid below their DEB, which they can do.
Okay, I will think about it. Thanks.
Eric?
Just to comment on this, on this last one where if this would be like the morning of an operating day. If they saw electric prices high that day, they could, yeah. So my comment is, it seems like you're kind of mixing metaphors. If a unit says, I have 6 months of storage, and then on the other hand, if prices go up tomorrow, I'm probably saying, but I can only run 3 hours, or if prices go up today, you're saying I'm only going to run, I only have hours, for instance, I only have enough water for 3 hours that day, so I want the third highest price that I think the price could be today. It just seems like you're kind of mixing metaphors between a very short-term constraint that would be set by the opportunity cost today versus a very long-term, a unit with long-term storage. So just to comment, the two together, I don't quite understand the logic.
So Eric, an upshot of what you're suggesting might be that not only do you have to worry about how long you look in the future, and there would be an upper limit to the number of months, whatever we look forward, there'd also be a lower bound. So if we have, a huge amount of, we have much more than 3 hours of water in the reservoir. If we have 500 hours, it doesn't make sense to think that today's day ahead peak is the opportunity cost. That if I don't generate in this hour, I'll have more water for today's peak when there's ample water. So it could be that there's, depending on the storage characteristics of the water and the pattern of water inflows, you both have a lower and an upper bound that realistically reflects that. So I think that's a good point that Eric makes.
Well, this is recognizing that we've been told that the hydro resources, they have long-term limitations, but then they also have shorter-term limitations within the day. They might have 3 months worth of water, but then they also have limitations for how much they can produce each day. And then so that the max is to recognize that when the next day's price is high, that you're going to be generating that next day, and then the short-term limitations would be binding.
Yeah. So I think we'd have to look. It would be good to look carefully at those because I understand short-term limitations in terms of things like you can't vary the flow too much because of erosion downstream, and you have minimum discharge and things. But it's hard for me to imagine, and they may exist, but it's hard for me to imagine that there would be a total water volume limitation that operates on a daily scale for a facility that has months of water behind it. That it could, such a facility, subject to the other flow limitations for ecologic reasons or erosion limits, it could generate for all 24 hours if the price is high for 24 hours, and there would be nothing to stop it. But there might be such a limitation, but I think we'd want to look at that to decide whether it's reasonable to put that day-ahead peak index in there as an opportunity cost. I just as my background as an environmental engineer, hydraulics, I haven't seen daily water volume limitations, total volume limitations for a reservoir that has a lot of storage.
But it might not be that. I mean, I know the Ontario ISO is building daily energy limits for their hydro resources into their day-ahead market model because it's so important for their resources. So at least in some places, daily energy limits are.
And then that might be because of upstream-downstream relationship.
Whatever it is, it is what it is.
Yeah, it'd be interesting to know what those. So when those do operate, then that makes sense. But I think
they're
there should be
building their look ahead intraday is going to be run out 24 hours because these things are so important for them.
Like I think the situation is, they have a series of reservoirs, and one is good for so much production during the day. Then they got to recharge it. You might have a month's worth of supply to keep recharging it, but there's only so much you can produce per day.
Yeah, okay, so you have a low volume reservoir downstream from a high reservoir, volume reservoir upstream. So on the Salt River, Teddy Roosevelt Dam has a lot of water, and then there are small dams downstream that the Salt River Project manages. So that's a possibility. I'm just saying that there should be some way to check that. There should be such a rationale that can be verified before that's put in there. If it's just a single reservoir and nothing downstream that constrains it, then I don't think they should be allowed to bid the day-ahead peak price.
I remember when we were developing the flexible capacity requirements and the eligibility rules for ISO hydro. I think it was PG&E hydro. I remember we came up with the number of hours they had to offer based on their typical daily limitation.
Even when they had many weeks or months of water flow.
Yeah, they had more than a day's worth of water.
Okay. So if there is a justification, great. But if there isn't a justification, there may be reason for some
resources. There might be some resources that have long-term storage and other resources that have daily limits. They might not be the same resource.
Okay. So I'll conclude to say that there may be, in some cases, a reason to truncate it on the lower side as well as on the upper side, when indices are considered. Other comments within the room? How about, we got somebody on the phone lines. Operator?
Caller, your line has been unmuted. Please state your name and question.
Hi, it's Mark Holman with PowerX. Just a couple comments. First, I think it's been discussed a fair bit, but there are myriad of constraints. There's fish constraints, there's recreation constraints, there's ice flow constraints. Some of these constraints are fixed, some of them are subjective. Trying to figure out what constraints are going to bind is going to be virtually unworkable. We know is that they exist and that we have two different index prices that are available as data. Another point that's important is that both at Mid-C, at BC, and in other Northwest resources, the participation in the EIM is also aggregate resources. So it's including multiple multiple different storage reservoirs within a single participating resource, because those resources are operated as a hydro system. And so you could be hitting constraints at one facility versus another. One of the points I wanted to make on and maybe I'll use it with a numeric example, is coming back to the point that I think was not really covered, or perhaps I didn't communicate it that well, is that the day-ahead peak index is the average price for 16 hours. The monthly index price is the average price of about 400 hours in the month. It is not a single hour price. It is not the best hours in the month. It is the average price across all those hours. So it really, when we talk about, hey, we're giving the best month, we're giving the best average monthly price. We're not giving all the best hours in that best month. And I think a numeric example will help on how challenging this is. Let's say you have a facility with a week's worth of water, and the day ahead on peak price, average price is 30, and the next month's price is 50. So you only have two index prices you can look at, a $30 daily price and a $50 for next month. It has a week's worth of water that it thinks it can sell before it runs out of energy. And it sees that next week is going to be really cold. And the seller is forecasting that it believes that the prices in the hours it's going to sell next week to sell it all its hours, all of its energy, is $80. This formula will come up with a price of $55. And if the participant's sitting there on a Wednesday or Thursday, price is $30, If market power mitigation starts triggering, it's going to start depleting that water at $55 on Thursday, Friday, Saturday, Sunday. At $55 and above, you're going to get into next week, and if that participant's right, they're now not going to have enough water to sell at $80 and, in fact, may end up being a forced purchaser to serve their own load. And so I just want to really highlight that the challenges in trying to get an accurate DEB, that we can use something like this formula. We need to consider other geographic locations where the resource is selling, but we need to acknowledge that the number that we're going to come out with, on some days it's going to be $10, $15, $20 too low. On other days it's going to be $10, $15, $20 too high. And when it's too low, we're running the risk of mitigation and depleting water out of these resources in the wrong hours. And that's the really big challenge that we've seen and we've faced. And quite frankly, it becomes more efficient to look at other markets and just self-schedule in the better hours that you think are above your estimate than to put an offer price into a market, let someone else dispatch at a price that is inaccurate. That's not to say you need a really high DEB. It's to recognize that we're not going to have all the information to come up with an accurate estimate of marginal opportunity cost.
Okay. I would say touche to that.
Another way of looking at that, is go in another direction we've talked about, is to say, okay, well, maybe then we should say we're not going to mitigate supply offered in excess of the base schedules and the flexibility requirement. And the only thing we're going to say is you ought to put in the economic offers and your low-cost resources and the stuff that you aren't holding for the really cold day to meet your base schedules and the flexibility requirement. And that anything beyond that, we don't mitigate at all, or we have a really high, standard of mitigation.
And I think, Dr. Harvey, that's going down the right road of saying, what is the quantity we should be mitigating? It's going to take a multi-pronged approach. Then how do we come up with a DEB for that quantity, but acknowledge that it's going to be wrong? One of the things we've said is that maybe you need a conduct exemption or a higher multiplier. If you come up with a DEB that's $30 and someone puts an offer into the market at $38, is the best thing for the market to say that $38 offer probably reflects a difference in their estimate of opportunity cost, or is the best thing to say that $38 is an attempt to exercise market power, let's mitigate it down to 30 because we think the 30 is right? I think we need to recognize that the number is going to be wrong. What quantity do we need to apply it to? How do we come up with a number that's reasonable given the limitations we have, and make sure that we maximize participation of voluntary supply while also sufficiently protecting for local market power?
I think one takeaway I get from your discussion, Mark, is that you think that there's a greater danger in too low a DEB rather than too high a DEB.
I think
so
there's a danger.
We should be cautious and err on the high side.
In my example, if the DEB is 30 and someone puts in a price at 120, the safer assumption is to assume that price needs to be mitigated. Someone puts in an offer at 38, the safer assumption is to assume they just have a difference in view of their marginal opportunity cost, and we shouldn't mitigate. And I think we need to just acknowledge that we're not going to be able to dig into these systems, try to figure out their exact storage length, how much water they have, what all their individual hourly opportunity costs at their different geographic locations for a year is. That's not going to come up with an accurate number. We need to get it roughly right and then recognize how imperfect it is.
I interpret that as an argument for a larger multiplier above the DEB as a safety margin or something.
I think that's part of it.
Okay. Mark, say that again.
I think we need to use a multi-pronged approach. A larger multiplier, we need to use something like this formula. We need to look at what quantity we need to mitigate. Again, the goal is to maximize participation while also protecting against local market power, and it's going to need to be balanced here with a multi-pronged approach in our view.
I think we've heard a lot of good ideas this morning, and I just, again, note Scott's about maybe, mitigating some resources, but not all of them, that maybe a mix might be interesting to explore. I realize that poor Don has to make a presentation after lunch too, so we want to make sure he gets his full lunch. He'll be on for the 15-minute granularity. So let me see if there's any more discussion at this point, and if not, we'll knock off when we're scheduled to, which is 12:15. Any more comments that anybody wants to make? The committee, in the room? Anybody else on the phone lines? Okay. So, Don, do you have any closing words? None? We'll see you again soon. Don't go far. Operator, at this point, we are going to break for lunch until 1:15. So we've got a full hour so Don can take his nap and charge the batteries.